Live custom. All right, great. Well, to repeat the message from earlier, welcome to the September 2024 version of the TwinCities.net user group. We are pleased to be joined again by repeat speaker and friend of TCDNUG, Mike Bankovich. Mike is, how many years have you been a Microsoft MVP now? So, Mike,
Oh, a while.
yeah, a long time. Yeah, good amount of time. We're lucky to get Mike. Mike speaks all over the world. So you name it, Mike's been there. So did you actually speak in Bangalore or did you just visit?
No, I
Um,
spoke twice been there speaking on in 2009, I think, and then 2011 or
yeah,
12.
yeah.
Yeah,
So
it's been a
yeah,
while.
Mike not only speaks, but he actively works throughout the Twin Cities for many good companies, helping him with application architecture, DevOps, Azure cloud governance. Very knowledgeable guy. Also, going to put a plug in for benkotips.com, Mike's website, and a group that he's very involved in, Tech Masters. So, really great group, learning some things. So, I always like to plug those two things that Mike's involved in. So, because
Sure.
just in case he doesn't get to that. Those are two really good things. I so there's some good stuff in both of those. So
There we go. There's my website. Look at that. It
oh,
still
there we
works.
go.
Oh,
So
look
that's
at this. I even
great.
updated my subnet calculator so you can do subnet calculation and split up subnets and do all kinds of networking engineering. Anyway, Um, you wouldn't necessarily need that, but it's kind of a cool thing. If you go to my blog and whatever, I've been around for a while. Welcome to my presentation tonight. It's the Jason asked me for a topic, and I said, "Well, what do you want to talk about?" He said, "Well, how about that modernize my compute?" And I had a slide deck that was all set for that, and all I had to do was just come up with a title. And I thought the joy of modernizing my compute, but that actually didn't work. In fact, I ran it through ChatGPT and I said, well, for this session, does that work? No. Joy of code, maybe code? Not really. Joy of .NET and .NET Core, like, because it's also, future looking, but, really .NET is kind of all cored out. And so it's kind of moved on to native, cloud native or microservices, the joy of microservices, which, is also kind of a alternate title. But microservices really, then you end up talking about containers. And if you're talking about the joy of containers, you're kind of talking about the joy of Docker. And I don't know anyone who finds joy in Docker. Um, to me, it's just kind of one of those things. So it kind of ended up kind of calling it a developer's dive into AZD and .NET Aspire, but it's also modernize my compute, which is the direction that we're going with all of this technology stuff. I've been doing this for a little while and kind of talking about what is the future look like and how do we modernize compute, how do we take advantage of all these tools, what is it that we can do that will make things work better and get us to someplace good. I used to have this picture of my purpose for being here, and it's actually been updated because now I've got a granddaughter who's pretty cool, and if you want to connect with me, my LinkedIn connection's on there. But I'm a local guy, live in Minneapolis out in Chanhassen. If you want to connect, I do Azure office hours every Friday. There's a bit.ly link. It'll go out to Calendly. It'll create a Zoom call for us. Talk anything Azure, 15 minutes free, whatever you want to talk about. I also have just recorded a couple more courses on LinkedIn Learning. They'll be coming out in the next couple of weeks, one on infrastructure as code and one on cloud governance. So those are the things that have been keeping me busy, at least lately. um, Digging into the technology and trying to figure out, exploring the possible has been kind of my byline of trying to figure out what it is that we can do and how are the tools, how do they make it so we can do it, do more in a more streamlined, faster, more efficient way. The takeaways from today was kind of talking about modernization, modernize my compute. What does that really mean? Do we want to talk about rewriting? Do we need to dive into microservices? If we do microservices, how do we run them? Where do we want to run them? Do we containerize? Do we do different kinds of virtualization? Do we do orchestration? And what's that level of investment that I have to put into creating creating code that works for everyone that's involved in this. So kind of talking about that, if you have any feedback or whatever, just put it into the chat and I'll keep the window open. And I just assume that if I don't hear anything, that everyone's happy with what's going on. If not, feel free to pause and we'll take a break. So a lot of times when I do talks, I talk about, what is .NET Core and why do I care? If I'm doing .NET Core and thinking about microservices, which means like very small programs, is that what a microservice is? Not really. It's a service that does certain kinds of things. Containerization, developer tooling, hosting options, all of that good stuff is sort of what I'm going to try to dive into and make it happen. I originally wrote this talk a couple of years ago when .NET Core was still a new thing. And I think it was 3.1 was the long-term, the LTS release, long-term support. And with the .NET Core 3.1, I have injection, I've got configuration, I've got a lot of options that make my code very portable and fast and run on different kinds of platforms like Linux. I can, all of a sudden, I'm a Linux guy because I do most of my deployments now into something that's running .NET Core that's running a Linux. And, it's like it opens up choices on how we want to do our hosting and run things. But when we think about, this whole architecture thing, this whole microservices or cloud native, what is that really? It's kind of, is it new? Is it something that we haven't seen before, or is it kind of taking something and just kind of moving the ball a little bit forward? Back when I was in school, we had this class called object-oriented programming with Lisp, and Lisp was a language processor where it was, you basically created an object-oriented programming, or OOP. And we would talk about doing object-oriented development and being able to do inheritance, and where I don't just have a class, but I have a class that has behaviors, and I could inherit from a like an animal class that is a dog class, and from the dog class I could inherit a schnauzer, or a golden retriever, and I might have different characters or characteristics or behaviors that they might do. One plays fetch, the other one just likes to bark. Um, but developing a true object-oriented system was sort of like data storage and the evolution of that, where we had the evolution of relational databases. The hardware caught up with it and made it fast enough that we could actually take advantage of it. With object-oriented, it was like there was Power Builder, there was C++, C# came along, you've got Ruby, you've got Python, you've got a lot of these different ways of going out and writing code. But it was like, how can I pull that back in and build something that has those characteristics, the minimal code, where I've got don't repeat yourself or dry. You've got these different principles of architecting and designing how you write code. The service-oriented architecture was one of the early versions of creating services that talk to each other, where you could create a contract that described how one service would work and connect up to the other ones that would use it. And if you version the original contract, then you could have different versions of this. SOAP, which was service-oriented SOAP, I don't know what it is, but was an extension from what was the WS Star, the web service set of standards, but it's going out and creating these service-oriented architecture to go out and do this. Microservices is taking that another step and saying, well, we've got a lot of these things, and we introduced the concept called REST. REST being a way that I can have from the command, or from a URL, be able to pass in certain verbs, get, put, post, delete, and then I can manage an object and have that RESTful endpoint be able to go out and create and do work for me. And so I take all of my different things and I kind of break it down into these different services, and I make it so that you can implement these in whatever language you want. And the languages get better and it gets easier. And it's like, okay, at some point we want to make this all better. So let's move it to the cloud and just make it all work. So .NET has evolved. We're now on .NET 9 is kind of in preview, and .NET 8 is the long-term service. It's cross-platform, dependency injection. You have all these great things, and I can work with it in a number of different ways. Some of the new features I can work with is how I can um, basically inject a service or a mock or a test and be able to automate a lot of the testing on things. So what I kind of want to do is I want to go into an application that I've got, and I created this. So I'm going to switch over here, and hopefully this will open up to that. And this is an application that I have written for basically going out and doing a quick little application. It's written in .NET Core 8. I've got injection of a couple of things. Let me do one thing here and see if I can turn on a tool I use called Zoom It. Code. Just a second here. So in here I have a injection of the Microsoft where I've got a using statement using the @, to say using the Microsoft extensions configuration. I'm injecting an iConfiguration, calling the variable name config, and then I'm using that config down here in my page to say, welcome, and then the name that's going to come from a setting somewhere. In .NET Core and beyond, you store these settings in something called your app settings file. So in my app settings, I have that environment name here. I also have a favorite color and a few other things. And what's interesting is that the app settings, instead of being web config, is a way that I can put in whatever configuration I want to work with, and I can modify it so that at runtime, when that thing goes up and runs, what I will see is that it'll go out and it will project that up in the welcome. Here's the environment name, and then I've got a background color for a style here. So taking this and going up to my C# file and saying, let's run this. This will go out, it'll build it and run my application. And the basic app is just a simple DAD app, if you'll call it that, that displays some great information about words of wisdom for my kids. So it'll get going here, and then it comes out, and here you can see, here I'm running local, and then I've got my environment information, and then you can see what's going on. So with that, I can use this and I can work with it. I'm in VS Code, which is a place where I feel kind of comfortable anymore. I've learned how to use it because it's the future. People say, oh yeah, you need to focus on the code. I even use the black background, which I think is interesting. But I want to, take this application where I've got one service and I want to make this run with a microservice, okay? And you could say, well, this is a microservice because I've got the call that's going out to this endpoint calling an AJAX call, but that's sort of cheating because it's just using a public endpoint. I actually want to write my own. And so in traditional development, I would have to go out and figure out how I would do that. In .NET Core and using Visual Studio or VS Code, I can do this pretty easily by going out here to my terminal, and I can use the command .NET new web API, and I can create a web API project and add it to my solution by simply adding the .NET new. And what this does is it goes out, and in my source folder, you'll see it added my API. And down here, it's got a program that's going to have a few things. I'm going to do a couple other things. I'm going to do .NET solution add, and I'll add that solution to it. So now I've got both of those. But this is the my API, which is a basic web API. And by default, it's using what's called minimal APIs, where I go out and I map out a get on a endpoint webcast or weather forecast, and it'll go out and return back some data. And it's using a random set of stuff. But to be able to call this from my existing app, I can go into the pages, and in my index page, I can add a little bit of code to do that. So there's two places that I'm going to add code. One is going to be in the index page, which is the markup. And I would have like my weather, I can do a form, which is going to use some form variables. So I've got a model forecasts, and I'm going to loop through and show what this data looks like. And then inside of here is my on get. And what I'm going to do is I'm going to come up here and I'm going to say my weather on get, and I've got some code that's going to go out and basically create a weather forecast. It's got an iLogger. I go out to create an index model, which is injecting in a configuration, the client HTTP factory, and a logger, setting the values on that. And then I'm going to kind of work through pulling up the weather forecast and then displaying stuff. And there's a JSON serializer. And I noticed that I've got the little red squiggly on there, which means there's an error. I can fix it by doing a control period, which then says use the system text JSON, and that'll deserialize that weather forecast. Now, doing that and keeping my forecasts here, I can take this and I can run this. So to run it, what I can do is I can go up to where I've got my program, and I can click on up here and say debug this associated file, which will start it up. That then goes out and builds the API project. And once it gets up and going, it should display a OpenAI Swagger interface for this. If I take this off and I just go to that /Swagger, or not, weather forecast. What I can see is that the weather forecast comes back and gives me back a set of data, and it's coming out at that endpoint. Now in a microservice land, I can take this and I can run my other project where I've got this guy, and I can run this one, which will start a second instance. And yeah, open API. And I'm getting, guess what? My HTTP client factory. And it's nice because it's telling me you've got an error. So how do I fix that? Well, I can tell that I didn't add the right set of code for that. So in my program file, where I want to use this, I need to go up to my web services, and I can say builder.services, add the HTTP client. And I've got my ChatGPT buddy running, so he suggests code as I'm typing. Well, that's kind of cheating, but I'll take it. So let's start at this version. And when this comes up, if we do this correctly, then I should be able to go out and get the weather forecast for this, which is something that we all want to have. So let's say no. And it's actually because it's running right now, so we'll stop this and go over here to my debug, and I can say, here's my API. We'll start that one. And that's the default configuration. And then once that is going, then I'm going to start the other one. So clicking on here, now it's building the app. And if I come down here and paste in the forecast, then it goes out and returns back the data from the microservice. So this is really cool because it's like I can jump in, jump out, I can pull in data. I've actually got two services now, and I'm like, oh yeah, microservices, me, man. It's all happy, and we're going. So using microservices, we're able to go out and build things that have a loosely coupled, bounded context, all of those great things. Scalable, I can scale things independently, I can version them, I can containerize it, and I can run it in different places. I can take this and I can make this my specific kind of thing that I want to go out and work with. But really, when you've got a lot of services, suppose I have 2 or 3 or 4 services, it gets to a point where it's actually gets a little bit challenging on how do I get this to run? Because as you saw, I had to go out and debug this, and I had to start that, and I had to run this. I had to jump on that. There's a project out there called Project Tie from the .NET team. And if you open up Project Tie and look at it, what it is it's an experiment from Microsoft that was originally brought out in .NET 6 that makes it possible to go out and develop and work with microservices easier. What I can do is I can go out and run this install of .NET tool for Microsoft Tie. And when I do that, if I come over here, let's go ahead and stop this thing. What I can do, if I go to my terminal and refresh this, is I've got my project and I've got my two services, and I've got a solution that has them both in there. Is I can, well, one thing I could do is if I run Visual Studio, I could actually go out and say dev env wgc poc.sln. WGC, by the way, stands for well-governed cloud. It's just kind of like a good starting spot for a well-designed solution. But anyway, I'm going to go out and I'm going to start my well-governed cloud in Visual Studio. And when that comes up, you can see here's my solution. And if I want to run this and debug this, you can see I've got my two services. Is I can go to the solution, I can say right click and I say, okay, configure startup projects. And I can come over and I can say run multiple projects. And I want to start both of them. So start and say, okay. And then I can say, go ahead and run this. And what it'll do is it makes it easier for me as a developer to have all of my different services start up and be available. Of course, they're running on my local machine, on the hardware, on the metal, which may or may not be what I want. Let's right click here and say rebuild solution. Looks like my API project is .NET 9. Let's back this up. .NET 8. Wonder if this is going to break anything. Shoot. Anyway, right click on this, go to our properties, take this and close it without saving it. No. But I am going to take this and I'm going to say my target framework on this is 8. And then that actually should update this. So now it's target 8, except the open API is kind of messed up. So we'll back that up to 8. And hopefully this would work. So if we build this now, and I can right click on this guy and say configure my NuGet package. And latest stable update. Now, see if that'll build. Apply, accept, and hopefully this will just work. So let's take this and save everything. And then let's build it. And this is the joy of getting into new technologies and just making it all work. All right. Well, if you could just believe me that if I had done this in the new version of Visual Studio, the preview with .NET 9 installed, it would have worked just fine. But VS Code has apparently got the new version on there. So what we can do is come back over here to this and take that, target that back up to 9. And yeah, I wonder if this is going to break everything. So we've successfully broken the project. What do you guys think? Pretty cool? But we can fix this. How?
We have no doubt you can fix it. We believe in you, Mike.
I think you should. I'm going to delete it, move to the recycle bin, continue. Yes. When in doubt, just blow it up. And at that point, because this is not the cool part, this is just like one of those things, right? So if I go here and I say .NET New Web API, and I should have said version 8 on that. But anyway. And let's run this inside of Visual Studio, enter the preview version. Visual Studio Preview. And let's just make sure that this still runs. So I'm going to click on this, click on Run. And getting these to run has been complicated. It's been, we spent a lot of time here getting this all to work. And what Project Tie is meant to do is to make that easier for us. And what it does is it builds off of the solution that has these two projects in it. And it will allow me to go out and specify how I want my actual project to work. So what I can do is I can go to this and I can say control period, take that, and I can say tie run. After I've installed tie by going through the tie installation, doing tie run basically goes out, looks at the solution, figures out what applications are there, and then goes out, loads a host for it, and then actually starts up a console for me in the browser that I can then use to manage how the application is running. And if I look at the dashboard by clicking at the local host, you can see that here's my app and there's my API. If I open up the app, I can see there's my local host. If I go to the project tie, take this right here, and I go to, here's my API and do that / weather forecast. Then I can take this, copy it in, and I can come over to this and I can paste it in. And there's my forecast. And you can see that, now I've got these two working and it's working inside of Tie, and I can actually view the logs if I want to. So I can look at the app and I can see how this is running, and I can follow the logs, and I can use this as a tool for debugging what's going on. In the code, if I stop it by doing Control C, then it will stop it. And in the console, you see its tie is actually exited, and then it closes the windows, which is actually kind of nice that it cleans up after itself. Now, using tie, I can also go over here and I can do a thing called tie init. And I can have some configuration settings going on inside of this. So down here, if I do tie init, it'll create a YAML file for me that describes out what the services are and how they work. And in here, you can see I've got information about the projects. I can have dependencies, but I can also do things like set up environment variables. And this is where that injection of configuration is actually kind of cool. So like my ASP.NET Core environment, I can set that to development. I can set my name here. And I can say the name of this would be my env name. And I can say the value of this is going to be tie. And I can say the actual, I could add the API and have the endpoint there. But the thing about this is that when I've done this and I've got this set up and available to me, when I do the Thai run and then open it up, it'll take those configuration pieces. And the YAML file is sort of like a Docker compose file where I can set up some dependencies and be able to link things together and inject different pieces of data. So now if I go out here and I run the dashboard and it opens up and I look at this, now when I look at my app, I can see that the app is, the Project Thai application. So the configuration comes in. But we still have things in microservice land that we need to, think about. Things like service discovery and, containerization. And, if I want to containerize it, how do I do that? Traditionally, when we go out and write code, I spent the bulk of my life, building code and then copying it out to a machine into a folder and then hoping the machine runs it. And so we build artifacts, we build those executables, we package them up, and then we copy the code to a running machine, and then we tweak the machine until it runs the right way. In containerization, where we want to run a lot of different things and do virtualization, historically, I could virtualize an entire machine called hardware virtualization, like running a VM, or I can do process virtualization. And process virtualization is where I want to be able to um, run lots of different containers. And so there's a question in here that says, can you use variables in the file for something like setting the base URL that's used in several places in the Thai configuration file? You can. And getting into how Thai does that configuration is great, but there's going to be a better spot. And I'm going to show you that in just a little bit. But just like in Docker config, where I can go out and I can specify things, because I think what you're talking about is going into this and saying in here. So one of the things in my app is when the page loads on index, I'm going and I'm reading this config setting for the API URL, and then I'm using that if I've got it to connect up to where I want to run. In my Thai config, let me take this and just move that off that screen. In my Thai config, I can have in here, the name for API URL. And I could say the value is going to be HTTP host 5001, assuming that I can do that. Or I could do my API and then do /weather forecast. And with this, then I could, when I run the application, be able to connect and link these things together. Good question. Does that answer it? And this is where I could, really be able to, keep my configuration and make it work together. But when I got a lot of different containers, a lot of different things, how do I do my virtualization? And we talk about containerization. And containerization is where I'm basically taking a machine and I'm going to copy in a file system that has the executable in a particular spot. Then I'm going to run that. And it's got all of the references and links that it needs to that is coming from different layers of operating system, where I'm basically, like in a Git repo, layering out the different types of things that would fit into it. And so instead of deploying code, now I'm looking at deploying images. And an image is a set of instructions of how to set up a machine to execute and run the way I want it to. I have a base image that might be an operating system, and then I layer on my files. I might layer on the .NET runtime. I might layer in a bunch of different things. And I put that into the container registry. And then when I want to instantiate that, actually create a container that is running with that, it'll go out and pull that manifest, pull that image definition, and then run it until it finishes and then exit out and do whatever. A given running pod or a container has that basic set of stuff. So to do that, we use something called Docker. And Docker is a great tool because I can go out and layer out how I want my stuff to be built out. Each layer is built as a diff on the previous layer, so I can just basically add and add and add the different things that I need. A simple Docker file has a core image that it's running. So here I've got my core .NET starting. I set a work directory. I copy some files in, and then I run something. The run section goes out and says, okay, do some stuff. And then I've got the environment where I'm exposing out like my environment name and maybe a port that I'm going to run on. And then I've got a command that's going to run .NET against that executable and actually start it. A more complex, like from VS Code or from Visual Studio, might look something more like this, where I've got, where I'm going out doing a .NET SDK, where I've got the full big SDK, and I'm building it, and then taking the output of that and putting it onto a place that's just got the .NET runtime. And so then I can copy that in and make that work. Docker commands are real simple. You do Docker build image, you create an image list, you can run it. And there's all kinds of characters you can put at the end of these, but it's, yeah, it's one of those things where Docker is like one of those games you're going to go out and say, yeah, let's go out and create a Docker file. This is going to be great. This is where Visual Studio does a great job of this. So coming out here to Visual Studio, and in here I've got my POC thing. And let's take this, and where'd my Visual Studio go? Here it is. So this has got my .NET stuff, and if I go out here and I run it, this is going to go out and it's going to take my two projects. And I'm running the preview version of it now instead of the .NET 8. That'll get updated soon. But this allows me to do that orchestration thing, but without having really added much to it. But anyway, what I can do is I can right click and I can say add. I can add a Docker support. And by adding Docker support, it'll go out and it'll say, okay, well, here's my container OS that I want to run this on. Typically with .NET Core, you're running on Linux. I'm going to use a Docker file, and then I'm going to create a distro, and it'll build this in a given solution. So using this, I can say, go out and add the Docker pieces to it. And then I can go out and I can do the same thing for the API, and we could run it using a Docker Compose. So let's do that. Add Docker support. And that'll add the Docker file. And if I minimize this, you can see here's where it's going out and using the .NET ASP.NET base. It's exposing out port 80 and 81. It does a build configuration, does a bunch of things with how this is from basis final and copying stuff out. I could add an environment in here for like I could say env and then say key equals value saying env name. Final env and say env name equals Docker. And if I take this and run it, so that does that. And if I add this on to this one and add the Docker support and say yes. So I'll build the two versions of it. One's in .NET 8, one's in .NET 9. And I can say, okay, here's my different projects, and I've got the Docker files. And I could say, you know what, let's do this, but let's do this with the Docker orchestration. And so I can do this with Docker Compose. Docker Compose will take the Docker file and add the distro for it. And this is, which one is this? .NET 8. So we're saying here, env, env. name equals Docker. And I can say Docker compose, go ahead and run this. And what it'll does is it goes out and takes care of building and doing all those Docker commands for me by packaging them up and allowing them all to go and run. So in the slides, if you look at what's going on, we use Docker Compose to go out and specify how we want things to work. We can put environment pieces in there. So like environment, you can put the environment name, you can have dependencies. I could do this and set up so that I have the Docker Compose files all working for me. So let's say no. Where's my Docker Compose file? There it is. So here's my image for my app. I would have some other things like my environment. And then come down here and I could say env name equals Docker. And I can have another config for the other service and say, okay, right click, add the orchestration support using Docker Compose and say, add that. And so then it has this. And then I can say, depends on. And I can say, depends on my API. And I can actually go up here and I can say, this is going to do the API URL is equal to HTTP, and then go my API, and then slash weather forecast. And if I do this right, and make sure that I'm not running here, and then try to run this with Docker Compose, it's going to go out and build out my containers and set them up. And it's going to compose everything and create everything I need. And it should actually wire it together for me. All right. So when this comes up and runs, and I can debug and get into the different parts of it, it's going to go out and say, here's my weather API. If I click on go, it actually should go out and then return back the results from that. But as you can see, I was able to pass in, configuration information and make that all work. Docker Compose, there's some good stuff to it, but it's also some challenging things. And the nice thing about it is I can use that to do some simple services, or maybe I want to run this in an app service, or if I want to run it into Azure Container Apps or Kubernetes. But where do we run it? If I want to run it, I build an ACR image and post it up there, and I go through a lot of work to make this all work. And right now I've got the container apps where I could run my container in. In fact, if I were to take this and let's go to the test here, I've got some script up here where I wanted to basically go out and say this is going to be TCD nug here. I wrote a script that's going to basically go out and use this for creating an environment for me. And so with this, I'm going to go out and I'm going to run the application, but I'm going to run it inside of an app service. And using the AZ command, I can run AZ web app to start this and run it. So if I go out and I set my directory to that point, and then I run this command AZ web app up, pass in the name of the resource group, which is going to be RG demos, passing in the event name. It'll allow me to go out and create this AZ. And let's take this command. And if you can see on my screen, I'm running the AZ web app up, and I'm using the free SKU, which is going to run the launch browser for me. And this takes just a little bit of time. But what it does is it's going to take my nice .NET Core application and get it running for me. So it creates the web app and sets it up. And then when it's done, it'll then let us go out and browse to it. And inside of Azure, if I go out and I log into Azure, logging in as my DevDad account, and close on these other windows. Inside of here, I've got a resource group that we just created for the Twin Cities .NET user group. And so inside of this, it's actually deployed out a app service plan and a app service. And the app service has some configuration on it, like environment variables. Doesn't have anything in there right now, but in my command that goes out and does the build of this, it should go out and actually create that. Now I'm going to run another set of commands to go back up here. I'm going to move up a couple directories and then come over to my API directory. And I'm going to do the same thing, but this time I'm going to do my API application. And when I do that, I'm also going to call this command called web app config to actually set the settings for the API URL to pull in the weather forecast from the API that gets deployed into that. So this is going to go out and it's going to use that same kind of thing. And if I look at this in my resource group and refresh, we'll give it a second to finish doing the deployment. But it's going to create the web app, do the deployment, and put it up there for me. This takes a second. And then it'll open up the browser. Inside of my resource group, I can see that this deployment is running right now. It's updated this. I should have the environment variable got set for me. So now I can see here's my env name, which is going to be set to be set to cloud. And do the show values. You can see env name actually doesn't have anything in it. I wonder why that is. Say app service, say save. And if we go back up here to this and we browse it, then you can see it comes up with the TCD-NUG website, and there's a weather forecast, and I can run that and be able to go out and work with it. But it's also running on Windows, and that's okay. But there are other options for how I want to host things, and hosting it inside of web apps for containers is good, but not best when you've got a lot of microservices. There's a lot of connections, lots of things you have to do. Another option is the app service for Azure Container Apps. Azure Container Apps is a fully containerized version. It's based on top of Kubernetes. It's got the Kubernetes control plane, but you don't actually get into it. It's like a managed version of AKS, but it supports being able to create different environments and connect things together. And to deploy to Azure Container Apps, you would think, okay, well, I've got to go out and do the same kind of thing. There's actually a new tool called AZD. AZD is the Azure Developer CLI. And if I use AZD, and let me close this out, I can run this command here. I can run AZD init. AZD, if you run AZD and for help, it'll tell you how to use it. It's a Azure Developer CLI that you have to install, but I can use it to scan code in my current directory. If I do this, it's going to go out and it's going to tell me what kind of code I've got and whether it thinks it has a solution for how I should host it. So it says it detected 2 .NET applications. I'm going to confirm and use that, and it's going to deploy this using Azure Container Apps. So you confirm it, and you say, what port is my API listening on? I think it's on port 80, and I think my app, if I look at the Docker file on this is port 80 as well. And then environment name would be my WGC TCDNUG 24. So this initializes this and creates a couple of files for me. In the folder Azure, it's got information about how this environment is configured. And the environment name has information. I've got some configuration. I've got the version of it. And then also down here, I have an azure.yaml file, which is like the TIE file, but it defines out the different projects and properties about it. Now, using AZD, I can do AZD up. And what it'll do is it'll go out and it'll actually configure all the things I need to be able to run this using the Azure Container Apps. And it does that by injecting infrastructure as code into my solution. Now you may see this green folder here, where this green folder didn't used to exist. It just got added by the AZD init command. And inside of the infra, you'll see here is a bicep file that defines out how this should be set up. It's got some abbreviations for different things. It's got some parameters. And it's got some modules that it's going to use to go out and deploy an app service environment, the dashboard, key vaults, monitoring, and also an ACR registry. And so the cool thing about this is it uses this infrastructure as code to go out and deploy out all of my infrastructure that I would need for this. AZD can also configure GitHub workflows or Azure DevOps pipelines. I can use that to be able to go out and basically set up the entire workflow of everything. So when this gets done here, I'm going to need to tell it which subscription I want to deploy this to. So let me make this a little bit bigger here. You'll see I'm sitting on my DevDad sandbox. That's good. It'll let me pick my location. We'll do this in central US, down here. And then the template parameters. So go up here and say AZD up. And this initializes things. Since I had accidentally typed in the wrong window up here at the top instead of down below, it kind of messed it up a little bit. But now it's coming down here and it's going out and it should actually build and do the deployment of everything for me. So I did this earlier and I've got that in my portal. If I go out to my resource groups and I look at my TCDNUG demos, what it does is it goes out and creates a number of different things for me. It creates app insights. It creates a couple container apps, the app and the API. It also creates the app hosting environment where I can use Dapper or things for like Redis caching and other components. It creates a container registry and a dashboard. If I go to the home and I look at dashboards, and I go to here and I say, here's my dash for this. There's my dashboard for performance on my container app. And I can see how things are running because that's part of the deployment, which I think is actually kind of cool. But using this, I can go into the app and I can then browse to it by opening up the container URL. You can say, here's my forecast and then the grapes and stuff like that. But that is one way of going out and getting my Docker and other things created for me. If I hadn't created the Docker file, it would do that, and I wouldn't even have to mess with even that. But The thing about this is that this is all nice and great, but there are other tools that are also worth knowing about, um, to be able to go out and do, hosting and working with this. And when you get into more complex stuff, Azure Container Apps works. You can use Dapper, Kita, single workloads. But there's also Azure Kubernetes. And Azure Kubernetes is a full blown Kubernetes instance that I can manage and do complex, large scale, lots of containers, lots of different images, be able to go out and run with a variety of things. And I don't have time to dive deep into Kubernetes tonight, but I can take that same container that we ran in either of the other two and be able to run it inside of AKS. But like I said, there was another tool that I thought was kind of worth showing, and that was this thing called .NET Aspire. And so what I want to do is I want to kind of go out and I want to show you kind of what we could do. I'm going to open up another Visual Studio instance, and hopefully this will open up and I can say, create a new project. And in this case, I'm just going to create just a sample starter project using this new framework they call .NET Aspire. So what is .NET Aspire? It's an opinionated framework or a set of components that let me go out and define how to do a modern cloud native application using NuGet packages and things like that. So if I search for Aspire and I've got the starter application and click on next, and we'll just call this my starter app. I'm going to put this into my code test, and we'll call this my Aspire app 3. Click on next. And this is the starter app. So I can use Redis for caching. I can create a test project. What do you think we should use? MS test, NUnit, XUnit? Since no one's besides me is talking, I'll just go ahead and use NUnit. Is that okay?
So, sounds good to me. I was going to vote for XUnit, but I am not strongly opinionated.
No,
Let's
use
do XUnit.
Cypress. Use Cypress. Sorry.
Use Cypress. It's not on the list. Sorry. Get on the list. We'll use XUnit. Click on create. And what it does is it creates a application host. It also creates some configuration that allows us to have a starter project that is going to have service defaults. So I've got some extensions. It's going to have some service defaults on it. How we're going to do resiliency. It's going to do service discovery for me. It's going to do instrumentation and monitoring. It's going to do logging. It's got a web application. It's based on Blazor. I've got the API service. But the cool thing about this is this Aspire app host. When I run this, it's going to basically go out and it's going to run everything I need for this modern cloud native happy spot. And inside of this, what you'll see once it gets started is that TIE dashboard, the TIE dashboard is on, it's like, wow, very, very cool. Give it a second to get started here, and then I can actually show you that. Maybe it's cool. Maybe it's cool if it works. So here it is, thinking. And there it is. And you'll see here's my Aspire app 3. It's got a project that's a web front end. It's got the API service. It even has a cache running, so I can cache things. If I open up the web front end and click on that, you'll see it's got the hello world. It's got a counter I can click on. I've got a weather, so it's actually integrated and using the weather app, so it's going through and pulling that in. So why is 10 degrees below hot and 18 below is chilly? Don't ask me. But what's cool is I also have not just this in the logs. I mean, I can go out and I can view the logs of what's going on, but I can also go out and I can do traces. And I can see here's the front end and here's the calls. And I can say, well, this one ran in 8 milliseconds. So that's a web front end call. And I can open that up and I can say, view the details on that. And I can see the dependency between it. So if I go back over here and I'm clicking around, I'm going to this, going to that, clicking there, and I'm refreshing, and I've got caches, so it's not actually updating that. But if I look at the traces, I can see where things are going and how it's running. So here's one that's going out to the API service, and I can see here's this call. If you view that, I can see the dependency, and you can get metrics on how things are running. I can even go out and say, here's a resource for my web front end, and then I want to say, what's my server request durations? And I can see here's the ones that were fast and slow. This dashboard is built in with Aspire when I run it, and I can get this whenever I go out and create that. And you might say, okay, well, that's kind of cool, but do I have to start with your sample app to make this all work? The answer is no. I can aspirate my own application if I want to. And the way I would do that is there's a couple different ways. In .NET, I can go in, I can say, here's my add.NET, and I can do this from the documentation, from the CLI. So I could add this entirely from the CLI, where you do the .NET commands to add the appropriate pieces for it. I could do it in VS Code, or I can do it in Visual Studio. The key is that when I do this, I want it to have everything I need to be able to work. So if I right-click on this and I say add, and I say Aspire Orchestrator support, this will go out and say, okay, well, here's my Aspire templates, and the .NET Aspire templates need to be installed and available in the version of Visual Studio you're working with. And if I had installed this in, if I had opened this in the other version of Visual Studio that has that workload installed, and I'm playing around with the versions of .NET here, so this is kind of fun. But I can right-click here, and I can say add .NET Aspire Orchestrator support. It'll go out and figure out what the projects are that are part of this. It'll create all the pieces I need. It'll add a prefix to it. It'll set up and add the application host, and then also the service defaults projects. And the application host is where they've got the part where it goes out and says, builder, add this project. And if I want to add the other one, I can right click and say add so right click here, add orchestrator support for .NET Aspire. It'll add this to it. And then it would basically add that line, which is going to go out and say, add this project. And the nice thing about it is that the dependencies between the projects and the services, doing service discovery and making it all work, it's, if I want to add a database and have the connection string, they'll do that inside of this as well. So the tooling is getting really good for being able to go out and work with cloud native and cool applications. When I go out and I take that Aspire project, I could run it and then be able to see how things are working. But there's a lot of stuff with Kubernetes we're not going to talk about. But the journey from going out and building a nice, cool app, sometimes it's a little bit more when you've got legacy code and you need to make it all work. But it's a journey, and it's going to be a lot of fun. So check it out, and if you have questions, reach out to me. Lots of options for how you run it when we get to there. But the tooling and exploring the possible, that's the fun part of doing this. So with that, I turn it back to you, Jason.
Outstanding. That's great. Well, thank you very much, Mike. That was outstanding. Applause, everyone. Just imagine everyone applauding. Round of applause. There we go. No one else is off mute right now. So I think if we just keep moving our, this sort of thing, I mean, eventually people will get on there and they'll say, oh, yeah, there's some fireworks. Woo, yay. Nice job. Very good job. But oh, confetti. Nice job, Mike. Very good. So, all right, cool. Do we have any other questions for Mike that people are willing to commit to the recording that might help other people. So any other questions for Mike? All right, well, how about this? We will stop the recording. Thank you. And then everybody stick around because we got a prize to give away, but